Okay, thank you for everybody because you are still waiting, still patient, waiting for my next video. Okay, I think this one the last part for impact testing. Okay, uh, continuation from the what we have discussed before for DBTT curve. All right. Uh, for this DBTT curve, okay, there is something like we call as several factors affecting the DBTT curve. Okay, the shape and position of the DBTT curve is important because it determines the transition temperature, which indicate where is safe to use for the required application. Okay, in simple word, this statement mentioned about we need to understand the transition temperature. Okay, let's say for example, when we when we plan to use the this metal A for certain, for example for bridge. Okay, we need to know, okay, what is the impact test if let's say the car accident happened and it crashed, the cable are made from steel, wire from the metals. So you need to understand the how can I say the properties or the transition, okay, or the requirement for the safe application for the engineering approaches. Okay, for this DBTT curve, okay, there is several factors that affecting the DBTT curve. Okay, number one, the crystal structure. Okay, number two is the specimen thickness. Number three is the interstitial atom, and number four is the grain size. Number five is the heat treatment, and then number six is the specimen orientation. Okay, uh, what is this factors means? Okay, number one, about the crystal structure. Okay, I think you know already. For you have learned in your first year. Okay, the type of crystal structure we have 13, I think 13 or 14 group of crystal structure: monoclinic, triclinic, rhombohedral, or hexagonal, etc. Okay, so this kind of structure as well affect the DBTT curve. Okay, in order to explain this, I think at the moment it's not I can say crucial for you to understand what is the factors that affecting the DBTT curve. As long, number one, you can list out these factors, and then as well you can need to explain some brief explanation. Okay, for example, for crystal structure. Okay, uh, when we talk about the DBTT curve for the metal made from the monoclinic versus the triclinic crystal structure for different metal material, so maybe the DBTT curve shape might be different. Okay, same goes with the specimen thickness. Okay, the next slide I will explain to you what is the influence of the specimen thickness. Number three is the interstitial atoms. Okay, let's say in metal, okay, there's a lot of how I say this, for metal is very famous, the interstitial atoms, because from this kind of mechanism for interstitial atom, the alloy has been produced. Okay, alloy is the combination from more than one metal element inside. For example, magnesium and aluminium, magnesium, aluminium and copper and others. Okay, so in these cases, okay, when you have the, let's say you from metal, you try to produce the alloy, you need to add additive inside. So this way, when this additive is, okay, there's something like interstitial atoms arrangement that might affect the DBTT curve performance. Okay, number four is about the grain size. Okay, as I mentioned in my previous slide here. Okay, grain size, where is the, okay, here we call as a grain size. Okay, normally you can see here's the grain size. Okay, in this case you need to understand what happened if the grain size is larger, what happened if the grain size is smaller. Okay, normally for large size of grain size is happen in the brittle region. Meanwhile, the small grain size uh, exists in the ductile metal. Okay, The next is the what is the heat treatment affects the DBTT curve. Of course, okay. Before I further explain what is the heat treatment means, okay. Heat treatment means that the additional process, okay, of the metal involved. For example, you fabricate let's say stainless steel alloy, okay, and then from there you perform something like hot rolling process, hardening process, hot hardening process. So this one we call it as a heat hardening, heat treatment process. This kind of processes involve influence the DBTT curve performance. Okay, and then number 246. Okay, 246. The last one is the specimen orientation. Of course, when you perform, because in the impact test we have CHAPI and ISOT test, right? The specimen orientation and position is also different for both technique. So therefore, maybe let's say if you do this variation of temperature for the impact testing using the CHAPI test, the DBTT curve trend, especially for absorbed energy, is might be different when compared with ISO test. Okay, uh, this one I want to explain about the effect of specimen thickness. Okay, I can say if the last specimen, okay, provide high constraint and then show the more brittles. Okay, why this statement happen? Okay, as you can see in the graph here, okay, this one sample for the large specimens. Okay, this imagine this chappy specimen level uh, refers to the standard dimension of the impact testing using CHAPI technique. But let's say if you fabricate the metal rod or whatever is more thicker than the standard one, okay, the result might shows less absorbent energy, meaning that when you increase the thickness of the sample, in comparison with the standard one, it might cause a brittle performance properties. Okay, and if you reduce the size as well, it might cause the different performance. Okay, I think this one I already mentioned, but I think this one is for your information only. Okay, no need to take care, no need to not understand in details. As long you understand the position of the sample during the impact test might play a major roles. Okay, major roles in order to understand the DBTT curve performance for that particular materials. Okay, and then you can see here in the transverse position what happened in longitudinal A, what's happened in the longitudinal B, is what happened. Okay, what is the hydrogen embrittlement? Okay, as I mentioned earlier, uh, in this case, okay, uh, the hydrogen might presence around. Okay, so therefore, the source of hydrogen is that the hydrogen might cause the embrittlement. What is the embrittlement? Okay, embrittlement means something like the hampir patah. Okay, have been encountered in the making of steel, in processing parts, in welding, in storage containment of hydrogen gas. Okay, when you install some things, okay, you need to consider the hydrogen embrittlement. Okay, in simple way, where we can get this hydrogen presence. Okay, where we can get the hydrogen present. Okay, because these hydrogens, okay, is easily attack and penetrate inside the metal. Okay, this hydrogen embrittlement might affect as well your metal performance. Okay, I give you and then this statement support here, blah blah blah, and then it's able to migrate into the crystal lattice of the basis metal. Okay, that's why uh, as I say just now, okay, this hydrogen is easy to penetrate and attack the surface of the metal, because this hydrogen able to migrate inside the crystal and then disrupt the structure. Okay, that's why the simplest example I can give you, imagine you do the experiment okay, using the acid hydrochloric, even dilute one, and then you conduct the experiment under the fume hood, and then inside the fume hood you put the metals. Okay, what happened to the metal? Although the metal position might be far from the container containing the acid hydrochloric dilute one, but over the time, let's say you leave it about 1 or 3 days, okay, the surface of the metal might be corrode later. That's why we call the hydrogen embrittlement. So meaning that the hydrogen from the hydrochloric acid HCl attack the surface maybe to the vaporize of the acid hydrochloric. Okay, that's why when you install something related to metal, so please make sure the acidic condition need to be excluded from the environment. Okay, here I can say how this hydrogen attacks and etc. Okay, at the moment it's not detailed about the explanation. If you want to understand in detail, you can Google up and then you can read from the articles related to hydrogen embrittlement for the metal. Okay, the key word here is that the hydrogen can attack the surface of the metal easily, because especially in this diagram, as you can see on my screen, if the surface of the metal have this crack or defect, I think the rate of the hydrogen penetration or rate of the hydrogen attacks towards the surface of the metal might be increased drastically. So uh, the metal is not suitable to be used, especially for oil and gas or acidic processing procedures, something like that. Okay, that's why they're keen to use something like glass-based material instead of metal materials. Okay, so remember, for hydrogen embrittlement, you need to prevent the presence of hydrogen surround the metal, and then again, the hydrogen is really easy to attack the surface of the metal regardless of its composition. That's number two. Number three is that if the defect created or presence on the surface of the metal, it might cause the hydrogen penetration or hydrogen attack is become more fastest. Okay, how to prevent the hydrogen embrittlement? Okay, now first, number one is that you can use this kind of things similar like what you have nanti you akan belajar in the corrosion part. Okay, corrosion part. The most major factor that cause the corrosion is from the hydrogen sources. So therefore, in order to prevent this hydrogen embrittlement, number one, we can use the mechanical coating or coating technique. That's number one. Number two, you can bake or heat to remove the hydrogen. Okay, for example, let's say you feel that okay, they have a hydrogen exposure toward the metal, so you can heat up the metal part inside the oven to remove the hydrogen content, because the hydrogen is normally present as a hydroxy group OH. Let's say when you bake it, the moisture on the surface might vaporize over the time. Okay, now it's become a summary. Okay, at the end of the impact test, okay, what I want to summarize here is that number one, uh, some materials are very sensitive to service condition, temperature. Okay, in this case, we choose as temperature and then show the ductile to brittle transition, which result in brittle failure. Okay, impact tests done at various temperature can identify the DBTT curve performance or properties. And then uh, again, hydrogen embrittlement is very easy for hydrogen to diffuse inside the metal. So I think that's all for my parts for impact. Okay, impact testing. So later at the end of this video, I think you have watched already my video for the hardness test, and then today you watch my video for the uh, impact test, and then this coming Friday I will do some reflection about the hardness and impact test as well. So Please wait for my further instruction, and then I hope you enjoy watching my video session. Thank you very much. See you soon.